Okay, so now I'm going to suppose that you're going to do the photo gates, okay? Uh, and I don't have it set up here. I can't show you exactly what it's going to do. But what it'll do is it'll drop numbers into a data table, right? So the way the photo gate thing works is that you've got a glider like this. It's going to have a little card on top of it, and you'll need to measure that length, okay? I'll call that, I don't know, X, okay? Measure what that distance is. Ultimately, what your velocity is going to be just the distance divided by the time that you get from logger pro. Okay, so when you get to logger pro, okay, this table here is actually going to display the time for you. You're going to get in there and it'll display the time, and it's not going to make a graph for you. So this is a little more advanced way to do it. Okay. And so your basically your momentum will be mass times velocity, which will be mass times x divided by t, right? So your uncertainty of momentum will be uncertainty of mass over mass plus uncertainty of the length of that card over the length of the card, right? Plus the uncertainty of the time, which will be almost nothing because it times down to a microsecond, right? Remember that these uncertainties are just 1/2 of the smallest value, okay? And so if your mass is down into, like, if you're 3.29 grams, right, that's plus or minus 0.005, right? Okay, and then your distance here, if you measured it down to a millimeter, it's down to 1/2 millimeter. And if you're down to a microsecond of time, then it's 1/2 of a freaking microsecond, okay? So that's your uncertainty calculation. There's your momentum calculation. And it really is so accurate. Generally, people find that the uncertainty is so small and that there is friction, so momentum generally isn't conserved. Your error bars are like, you're like, and, there's no overlap here. It's like, okay. But that's okay. You get to use photo gates, which, at least on the face of that, that's pretty fun, huh?